Hello?
Hey
Hey
everybody,
everybody, it's Brian and welcome to the 48th Qt tutorial with C++ and GUI programming. Today we're going to be continuing our conversation about the model view architecture. Hey everybody, it's Brian and welcome to the 48th Qt tutorial with C++ and GUI programming. Today we're going to be continuing our conversation about the model view architecture, how that really relates to your daily life as a programmer. We're going to cover another predefined model called the QDIR model. So let's just call this dir model. Put it in the usual location. Next, and let's do a Q dialog. Finish. Alright, now that we got our dialog in, let's just throw a couple push buttons on here. And if you have the official Qt book, then yes, this is pretty much straight out of the book, changing a few things just for the sake of time. After our tree view, remember, whenever you see the word view, that means it follows the model view architecture. Resize these appropriately, set your layouts. Let's just throw a horizontal spacer in there, that way our buttons look semi-normal. And we're going to make directory and delete. Okay, now that you've got your layout done, pretty simple layout, I know. Let's actually flip into the code here. And we're just going to add our includes. Oops. Having keyboard difficulties tonight. I apologize. Alright, we've got that in there. We're going to just create a new QDIR model. Let's just call it model. Flip back into our real case here. It's actually just create these signals and slots we can combine them. Just kind of going through this very quickly. I was just sort of rushing to make videos just because we're running out of time so fast. Right. Now we're in our implementation file. The first thing we actually need to do is create and populate our model. And to do that, we can actually just create model. It's a model. Remove. Say this is the parent. And one thing we should note is we should make the model not read-only. If it's read-only, then you cannot modify the file system. Now you may want it read-only. For example, if you're making like a file open box or something. But in our case, we actually want to work with the file system. And let's just do a UI preview set model. I want to show you exactly what this looks like, just so we can continue. Compile and run. This won't have very much functionality, but you'll get the drift of what's going on with this thing. Compiles and actually runs. Okay. Here we have. I realize I have a lot of drives. This is my gaming/development machine. We have a list of drives, and this is just a tree view. The underlying model is actually our file system. And you can see how it's kind of haphazard and nothing's sorted. And well, we're going to fix all that, so bear with me. But I just wanted to show you the rough idea of what we're trying to accomplish here. We'll be able to make directories and delete files. Let's close that. Right now, let's say we want to do the sorting first. So let's go model, set sorting, and we need to use the QDIR flag. So say QDIR. And we want DIRs first, or directories first. We want to ignore the case, because we really don't care. We want to sort by name, so same name. Very simple. What we're saying is we want the directories to be listed first. You also notice we could list the directories last. We want to ignore the case and then sort by name. Then what we want to do here is, let's just get rid of that extra line there. It always kind of annoys me. We want to actually have this automatically select my drive. So secure model index. Once you start working with the model view architecture, you realize just how important that the cube model index really is. So there's model, and we want the index of, and we're going to give it a path here. Now, what you could do is that, but one thing it does is it automatically translates the forward slash. It's kind of like a universal translator for the path notation. I would not, for production applications, recommend hard coding a path in there, but this is just tutorial, so we can get away with that. So UI, tree view, and we want to expand. And what we're doing is we're getting the index of the F drive, and we're going to actually find it in the tree view, expand it. Let's just work a little copy and paste magic here. And then we want to scroll to. So we want to scroll the view down to it. That way we don't have to go hunting for it. And we want to actually select it. And then we want to resize the column to the contents. And we just want the name of the first column. Alright, save your work. Let's actually run this. See this thing in action here. And wow, doesn't that look a little better? Notice how it's sorted by name. It ignores case, and the directories are first. It found and selected the F drive, and it scrolled to it. Pretty neat. Now, one thing you should know is that you already have the ability to rename files without even adding any extra programming in there. So you should be careful when you're working with this that you don't inadvertently delete files or rename files. This is actually working with your file system, unless you have it in readable, which we don't. So let's go in here, and what we want to do is be able to create directories. So we say Q model index equal UI tree view current index. And we want to make sure we have a valid index. So we say if index is valid, and I should say if not index is valid, sorry about that, then return. So if we don't have a valid index, then we just jump right out of it. So QString, now we want to get the name of the directory. We want to use a Q input dialog, and we want to get text. This is the parent, and we'll say, let's just call this name. That's the title. And the label, say, enter a name. And one thing we want to check here, apparently we have a boo-boo. What is the parent? We got the parent, we got the title, got the label. Not quite sure. Yes. So I mean, sorry.
Long day at work.
Probably check one. So we want to make sure we have a valid name. So if the name is empty, then we just want to just jump right out of here. And if all goes good, we've got a valid name, same model. make dir, and we want to actually get the index. That's the parent. Notice how we got the current index up here. And give it a name.
It's right there.
There. So let's actually run that. Let's see if we can create a directory here. So we've got our F drive selected. And let's just make a new directory.
And
there it is. AAA. Okay, now for the finale of this tutorial, we're actually going to delete stuff. So let's save ourselves a bit of typing by just copy and pasting here. And one thing we want to do is say, if it's a directory or if it's a file, we have to handle it a little bit differently. So and you can actually, from the model, get the file information from that index. And from that, you can pretty much do whatever you want. You can determine if it's a file, if it's a directory, get the base name, etc., etc., etc. And then you can use qfile, like example if you want to do something. But in this case, we want to just say, is it a directory? If so, then it's dir. Otherwise, it's a file. And we have to handle this differently. So to handle directory, we'd say model, remove dir, and you just give it the index. And for files, you'd say model, and you just say remove. Pretty simple. Let's review real quick before we run this. Basically, you're getting the index from the retrieve current index, and if the index is not valid, then you just break out of here. Then you say model, get the file information for that key model index. If it's a directory, then do a remove dir. If it's a file, then just do remove. So let's save and run this. So let's actually get rid of BBB. Sure enough, it's gone. Let's get rid of AAA while we're there, just to clean up my hard drive a little bit. Alright, and let's delete that clock right there. So, there you go. That's the Q. What is this again? Q-dir model. Sorry about that. It's been a very long day at work. One thing you should know about the Q-dir model is that it's actually been replaced. And what do I mean by that? Let's go into Q-dir model. And what it says is the Q-dir model class provides data model for local file system. If you click more, it actually goes in and says the usage of this is not recommended anymore. Use Q file system model instead. Well, what's the difference between Q-dir model and Q file system model? Well, the biggest difference, other than they don't recommend using Q-dir model anymore, is that the Q file system model is actually asynchronous, which means it won't lock up your GUI. But with everything, it's got its own little complexities that you have to deal with. We will cover the Q file system model in another tutorial and try to discuss some of those complexities. But that's it for this tutorial. Thank you for watching. I found this educational and entertaining. Hey everybody, it's Brian, and welcome to the change it layer. Make these signals right. It's read. I list suite box. And help fill in on parent. I'll just do it. Does but so there it is. Let's if they work at the title. Check here. The label. Jump for an we don't care first. Do spam. Let's like the let's kind of get the help out the things back with the daily Q tutorial with C++ and GUI programming. Yeah.
Everybody, this
This
is
is Brian.
Brian.
Welcome to the
49th
49th
tutorial
C++ and Groove program.
Today
Today we're going to cover the Q file system model. So a little bit today.
So
If you haven't already, go out and look at the Q file system model class reference and you get this class. And if you watch my last tutorial, we covered the Q-dir model and tree view and how that goes together. And what is the difference between the Q file system model and the Well, they're both models. They both use the file system to get their data. But the Q file system model is asynchronous, meaning it won't lock up really while it's sitting there querying the file system. So if you're using the Q-dir model and finding your user interface is locking whenever they click on something, switch over to the file system.
Now I've
I've already got the user interface done, and it's a very simple one. It's just a tree view on the left and a list view on the right. This is where we load folders and the files on the right. Simple little Explorer application.
Alright, I've got some
includes already.
The Q-core and the GUI.
And let's just dive right in. So we say Q file system model. So the model. And Q file system model. Cross file model. Now you might be asking yourself, two models here. We can attach multiple views to the same model with both the same directory. We need to filter these. We want the general model to only display folders and file models to display files. Let's see what makes sense. Let's go into dialog CPP. And first let's set up the tree. So let's say model. Q file system model. What that does is it creates our new model.
And what we need to do now
is we need to actually populate this. So let's get a look at it. String. So let's find. And what we want to do is just get a path. So I'm going to use my F drive as the root path. The reason why you need a root path is because the Q file system model will not do anything until it has a path. So once you say it has a path, it actually goes out to the file system and says, okay, give me everything in the path. And that's how it populates the model. So UI, preview, set model, and this is where we actually set the model to the view. Attach those two together. If we save and run this really quick, I say really quick, first you click second build. Build times may vary. My computer's kind of going slow as embarrassing. You can see I've got all these hard drives, and I've set root to F. And you can see how it's showing folders and files. We want to get rid of it. We only want to display folders. So let's go in here. What we need to do is we need to set the filter. Whoops, there we go. We do that by saying Q-dir. No dot. And Q-dir. I should say or. And we want all dirs. What that'll do is only display the directories and the dot and dot folders. So let's save and run that again. Just kind of show you how that's working. Now when we go in, it's not displaying files anymore, it's only displaying folders. What we need to do now is we need to go to slot on the tree view, and notice that's got the Q model index. That gives us the Q model index of the node. Let's leave that for now. What we're going to do is to actually implement this view. So we'll say file system model, or I should say file model equal Q file system model. And pretty much the same thing. Just need to set the filters. So just do a little copy and paste magic here. Instead of directories, what we want to do are files. So our list is only going to display files. That's why you need two different models, because you have two different filters set up. Right. And we can say URL, this view, set model, file model. And that will set up our list view. Now, when the user clicks on the tree view, we want to be able to A, extract the path out of the tree view, and B, set that path to our list view. So, string, this path. Wow, not spelled path, sorry. And what we need to do now is get the path out of that dir model. So we can just say file like that. And also takes a few elements, so you guys can put the index in there. And then we want the absolute file path. So we're just saying dir model file info for the index, and then we'll say absolute file path. And that will give us the full path the user just clicked. Now we say run this view, and we want to set the root index. What that does is it sets the index for the root. So it's already got the underlying file system, and we're saying, okay, find the specific thing. Say file model, set root path, and we give it the path that we extracted out of the tree. So we're doing a couple things here. Let's review really quick. Scroll up to the top. Alright, we are setting up our dir model and setting up the tree view. Then we're setting up our file model and setting up the list view. Then when the user clicks on something in the tree view, we're extracting the path out of the node using the file info, absolute file path. And then we're saying list view set root index. We want the index of set root path. Save and run. And there's this thing to go. I really should turn fire scan off in a bit. I apologize. There we go. Now, when you click on something, see how it only displays files. Over here, it's displaying folders. Oh, cool. Let's go to source code. And let's just see, notice how the icons are extracted from the underlying file system. So very quickly, we have just made Explorer-style application. I realize this is very rudimentary, but something like this in other languages can take you just hours and hours and hours of coding. But using the model view architecture, it's actually very simple, especially when you use the file system. Now, I should note you can accomplish roughly the same thing using the dir model, but the file system model is asynchronous and not linear. So this is Brian, and thank you for watching. Thank you for this video education. Everybody, this is Brian. Welcome to the 49th tutorial of C++.
Hey everybody,
this is Brian. Welcome to the tutorial of C++ and GUI programming. Today we're going to cover delegates. In case you want to know what a delegate is, there's a lot of examples out there about spin box delegate. It's actually built into GUI programming. You go choose example, item views, and then spin box delegate. You get the complete source code for something very similar to what we're about to do. But basically what a delegate is sitting right here. Allows you to view an item within a model, and you can decide exactly how to do that. What we got here is basically a model with a table view, and in the table view, when it goes into edit, there's a spin box sitting here, so you can change that to whatever you want. So let's go ahead and actually build something. GUI application, let's call it delegate get.
put it
in
in
the
the
user
location.
location.
Let's
Let's
just
just
give
give
it
it
a
a
dialog.
dialog.
Next,
Finish.
Alright.
Maps. Dilihat what? Tidak, dilihat rumah. Yeah.
And let's grab
Grab
a
a
table
table
view.
view.
Have that
Get
out
out
there
there
real
real
quick.
quick.
Save
Save
your
your
work.
work.
Alright. Now the
Well,
first
the
thing
first
we
thing
want
we
to
want
do
to do
here
here
is
is
actually
actually
go
go
to
to
dialog.h.
dialog.h.
And we're
And
going
we're
to
going to
create
create
our
our
models.
model.
Let's just make a
Just
few
do
inputs here.
includes here.
And
And
let's
let's
add
add
in
in
the
Q
standard.
standard.
Sorry about
Sorry
that.
about
The
that.
Q
The Q
standard
standard
item
item
model.
model.
What this
What
will
this
allow us
will
to
allow
do
us to
is
do is
just
just
make our
make our
own
own
model
model
with our
with
own
our own
data.
data.
Pretty much
Pretty much
anything we
anything we
want
want
to
to
throw.
throw.
Now we'll say
So,
model.
model.
We want a new
New
Q standard
standard
item
item
model.
model.
And the
And the
constructor for
constructor
this
for
is a
this is
little
a
bit
little bit
different.
different.
What we
What we
want is
want
the
is the
number of
number of
rows,
rows,
number of
number of
columns,
columns,
and
and
the
the
Right
increment.
and some holiday that they.
Then we
then
can
we
go
go
ahead
ahead
and
and
attach
attach
this and
this.
say,
Oh my gosh.
say work. Now,
Now,
there's
there's
no
no
data in
data
our
in our
model,
model,
so if
so
we
if we
run
run
this, it's
this,
not
it's
going to
not going to
explain
explain
it.
it.
So what
So
we
what
need
we
to do
need
is
to do is
actually
actually
generate the
generate
data
the
for
data
this
for this
model.
model.
We're going to
We're
say
going to
for
say
each
for each
row,
row,
rows less
rows
than
less than
4,
4,
Okay.
and we're going
to
to increment the
increment
row.
the row.
And then for
For
each
each
column,
column,
forgot to
got
type
to
there.
type there. less than 2,
we're just going to increment it. Now, how you input data into your model is very simple. First thing you need to do is give the index to it. So say Q model, Q model index. Let's call this index. Put that out here. Equal. Say model. And we want the index of a specific row and column. So row, call, and it's going to want a parent. And for that, you can just give it a new model index. Semicolon. And that's how you grab the index. Now it means there's actually set data. And it's going to, of course, want the index of the item. And for this example, let's just get 0. See if we're working, right? What this does is it just pre-populates our entire line with data. All of it's going to be 0. So after this fills and runs, you see there's a model. Now, one thing you should remember walking into this is Qt has this function already built up. So in the edit mode, there's the sprint. But we're going to show you how to complete custom sprint box all over your own. Okay, now,
what we need to do is create a new class. And we're going to call it delegate.
And its
base class. Its base class is going to be a Q item delegate.
And it's going to inherit from Q object. And then go into dialog.h.
And you'll see we've got just a very simple class here. And we're going to have to add a few includes. We need Q model index.
Q
object. We need Q size. And of course we're going to need the spin box. So. Now, we've got a class which inherits a Q item delegate. One thing we should probably do is go to the help file and look up Q item delegate, see exactly what's going on. The Q item delegate is a class that allows you to create your own delegates. You see the virtual functions here are create editor, set editor data, set model data, update geometry, size, etc., etc. We have to actually implement these virtual. Alright, so let's go out here. Now one thing you can do is just copy and paste. It's almost a little bit easier just to actually let the editor do work for you. See how it just puts everything out there for you, so it really minimizes your typing. I'm not a big fan of typing, so I say, you can go with that. Let's do it. And we're just going to create a function prototypes here. Semicolon there. And let's do void. Update editor geometry. Now, if you're wondering what these do, actually very simple. When this is first run, the delegate doesn't even exist.
So the
view will call create editor. That will create the editor delegate background. Then it will call set edit data, which is the data itself.
You
then modify it.
When you're done modifying
it calls set model data to return data back model. Update editor geometry is how the Q spin box actually knows how big it needs to be and where it needs to be on the screen. Without that, it just floats into the upper left. But we'll kind of see that later on.
And you can just copy these.
Go right into your implementation file.
Paste them.
And through the magic of copy and paste,
you can
just implement these really quick here. And at this point, I'm actually going to pause the video. I don't like chewing up a whole lot of video time just copy and pasting, so I'll be right back. Alright, I'm back. I've got the implementation file pretty much fleshed out. Now, one thing we should do is go back into our dialog, and let's actually include this one before we forget.
And then we're going to create a delegate here.
And let's call this delegate.
So
Let's call my delegate. Alright. Now we'll grab this, we'll go back into our dialog implementation. Let's actually create one of those in that. So we say my delegate with the delegate. And give it this. That way it's in memory. It's ready to go. And let's actually set the delegate. UI. Set and delegate. My delegate. That's how you actually set the delegate. And you should know if you don't set this, it'll just use the default delegate. Jump back into our delegate implementation file here. And this is where the real heart of this program runs. So remember the create editor, this is called when the view needs to create the editor. So Q spin box. And we're going to create a new one of these. And you just want to give it to parent.
Okay. If you log in, I will play one video for you. If you brought in, okay, I will. Panasonic. Yeah. If you brought in, see this video. Forget. Yeah. Looking back to this video.
And very
Very
simply,
simply,
you
you
just set
set
the
the
minimum and
minimum and
maximum of
maximum
the
of the
track.
track.
So
So
we
we
just
just
say
say
No technology with the basic.
set minimum,
we want 0
0
is
is
the
the
minimum.
minimum,
With the try house. The try. Keep going.
and then we say maximum
100.
100,
Keep going.
and then we just simply
Keep going.
return the editor.
Don't give up.
Because at this point, the only thing
Yeah.
he cares about is to grab
Yeah.
this editor so it knows it has it,
And
and then it
it
can start using it. Once it has it and it wants to start using it, it calls editor, or I'm sorry, it calls delegate set editor data. This is how the data gets from the model view architecture into the delegate itself. So, first thing we need to do is get the editor. Sorry, get the data. We get the model from the index.
And
And then we want to get the data. If you're wondering what cute edit rule means, each item in a view has a different rule. What we want is the edit rule. And we just simply want to say to it. So very simply, all we're doing is we're saying we want the value out of the index. So we do that with the model and the data out of the edit rule. Sounds pretty complex, but it's actually not too bad once you really sit down. So then we have to put that value into the spin box. So spin box. We'll just call this spin box. And we want to do a static cast. And let's just casting the editor here. That's how we know what type it is. So spin box. Oops, it's spelled. And we're just going to set the value there. Remember, you're getting all these from the parameters. So value here, setting the value there. Now the set model data, that is when you are done adding it, and you want to return that data back. At this point, let's actually just run this program without even looking at it, just to see what happens. I wish I had some really cool theme music so when I was building you could just play it. Here is your model here. And when you enter edit mode, notice how our spin box is up in the corner. It's because we haven't called the geometry yet. And if we just enter 55, notice how it's not going back into the model. But when you start, it's automatically 0. Because we're going to implement the set editor data, that's how the data is going from the model into the delegate. Now we have to take the data from the delegate back into the model.
Yes.
So, spin lines. And we can, you guessed it, just work some copy and paste magic here. Save some time. And we will say spin box, and we want to interpret text. That will force it to interpret the value that's been put into it. Say it. Value equal spin box value. We want model. We want to set data. We're going to put the data back. Put the index and value, of course the rule. That way we know this is coming from the rule. That's how you put the data back in.
And we of course want this to be placed correctly. So let's just do an editor, set geometry, and we want the option parameter. So really all you're doing is you're saying the rectangle of the cell that this came. Save and run. And let's do this one. Notice how it is set geometry, put it in the correct place. We type 55 and exit edit mode. It puts it back in the model. Go back in. There it is. So it's set 4, just 88. You can see how this works. You can use the spinners up and down. Notice how when it hits the minimum, it stops. Put it at 99, try going up. It won't go past the number. Pretty neat. So that is how delegates work. I realize this is a very simplistic example, even though it may sound a bit confusing. One thing that you should do, if you just kind of shook your head at this whole example and what is talking about, is go into the spin box delegate example, and we have the complete source code there, along with the official Qt documentation and instructions. So this is
okay.